how it works. Could one give a definition of blockchain? Udeus? Go ahead.
I would define it as a register that holds the transaction in the network, and framework that powers it. Is that a fair assumption?
Yeah. It's a good try. It's a very hard problem to define the blockchain. There's many people that do it, and most of the time they do it in a technical sense. The technical definition is a distributed database that holds a single ledger openly. But you could also say, when you look at it from a business point of view, you could say it enables transactions, makes it possible to do a transaction from A to B. And legally speaking, you could say a blockchain validates a transaction without the need of any trusted third party like a bank or whatever. So there's many definitions there. And the blockchain capabilities is a mix of all these three. So technically, business-wise, and legally. But thanks for the good try anyway. I want to start off with a small anecdote. In 1972, we had a small Henkie. Henkie is 7 years old, and he has this savings stack of coins. You know, this where you can put plastic pipe where you can put coins in. Have you ever had them? Yeah, I see somebody nodding and rolling his eyes. So the stack of coins, I was very proud of that. And it grew and it grew and it grew. One day Mama came in and she said, well, let's go to the bank and we'll give the coins there and you'll get a surprise. So I took off with my mama to the bank, very happy. And then I had to wait in the queue first, and then I had to give my stack of coins through the occasion to a person that I couldn't see because it stood me. And I grew very doubtful there. I was unsure what would happen to my stack of coins. And I heard a lot of noise and people talking. And then in the end I got back a note, and it was written 125. I got a simple note, 125, piece of paper. So my mama needed half an hour to comfort me outside of that building. And I can assure you, it never gelled between me and the banks ever since. You know, I wasn't happy with them. Now, 45 years later, I discovered something like the Bitcoin. It's 2.5 years ago, more or less. And under the hood of the Bitcoin resides the blockchain. And the blockchain is a quantum leap, as Dave said before. It's like the invention of the web on top of the internet. It will have the same impact in the future as the web did 20 years ago. All right? But let us first look at some news facts that came to you by the media about the Bitcoin. Any prejudice, let's say, stories, whether they're true or not. Could you name a few stories?
One guy claiming to be owner or the inventor of the algorithm, right or something? In the news 2 weeks ago.
All right, Satoshi Nakamoto.
Yeah.
Satoshi appeared. All right. Or did he disappear? At least in 2012, he disappeared in a puff of blue smoke. He was gone. Right? He's the inventor, supposed inventor of the Bitcoin, and was maybe very surprised himself when he discovered the effect of the blockchain below. Right? Any other stories or prejudice about the Bitcoin?
Silk Road, Mongols.
Sorry?
Silk Road, Mongols.
Mongols. So the Mt. Gox disaster, everybody knows about that? Don't think so, I will explain briefly. Mt. Gox is an exchange, and the Bitcoins people held in this exchange were robbed 2 years ago. A few of myself too, so I felt it in the first instance. So, Mt. Gox is an exchange, and it's centralized. So it's got nothing to do with the Bitcoin protocol. It's got nothing to do with the capabilities of the blockchain. It's just a simple centralized exchange where money was robbed by either an external party or an inside job. And the CEO of Mt. Gox is now in jail, so that might imply that he's got something to do with the disappearance of the Bitcoin's Mt. Gox. Alright, we check that one. Satoshi, can do a quick on that one. Satoshi disappeared. It's very easy for Satoshi to prove that he's the one. He just has to transfer a tiny little bit of Bitcoins to another address. And I won't even go into detail, but it's very easy to prove that he's the one. But Craig White, one who says he is Satoshi Nakamoto, does not do that transfer, at least as far as I know. Right? It doesn't really matter whether we know Satoshi or not for the Bitcoin, because the Bitcoin and the blockchain protocol is totally independent of individuals. You could participate or leave again. Right?
But if somebody leaves his money, he will not participate in any transaction. Where if he person disappears, if his private key disappears, then his money will go forever and will not participate.
Exactly. Yeah, that's a good point. You want to bring that in as a right? Yeah. I would say vulnerable. Is that the right spelling?
Vulnerable.
All right. It's vulnerable. Kwetsbaar. That's true, very much true. We haven't got all the services in place yet because the blockchain is in a very early stage of development. So we haven't got all the services in the right place to be resistant against stupid acts. For example, you lose your private key. When you lose your key of your home, you can remake some and enter your room again, your house again. If you lose your private key of a Bitcoin address, then that money is lost forever. So that's really a good point you made there, Alexander. Someone else?
Block size debate.
Sorry?
The block size debate.
Block size debate. If you don't mind, I won't go into detail of this one because it's for the next meetup. I might get back to this one if we explain the actual working of the blockchain. Right? Okay.
What's the rate forecast we can make here?
Sorry?
Because some people consider that the current rate of Bitcoin is quite unpredictable.
All right, follow down.
Yes.
Let's follow down. Yeah. Is that the right word?
I've
Yeah.
used volatility.
Volatility.
And that, for anybody who's not actually foreign, is the way that the Bitcoin or cryptocurrency prices tend to go up and down, almost randomly in response to market pressures, which makes it kind of tricky to actually pay directly to Bitcoin.
I would advise anyone who wants to buy Bitcoins or Ethereum or any other cryptocurrency, just take your euros out, set them alight, burn them, and then go into cryptocurrencies. If you don't believe and/or exchange money to cryptocurrencies, which you need for your personal, your daily life, I shouldn't go into cryptocurrencies because for me it's a one-time step. You convert them and you will never go back to fiat currencies. Why would you? Cryptocurrencies are better designed than normal fiat currencies like euro, dollar, etc. you will see a lot of people go into cryptocurrency and return. The currency, the exchange rate doesn't really matter. Of course, it comes in handy when it's a bit stable. People feel more secure, and speculation is less on cryptocurrencies. But normally it's just another. It's a totally different way of life, work, value. All right, we'll go into that. But I'll explain first, if you want to understand the blockchain, I will first explain a transaction. And a Bitcoin is more or less like a transparent house with, I put it in a few fiat currencies. There's euros there, 3 euros. If you would like to transfer this, for example, to, let's say here in Bas, and I want to buy a pair of alpaca socks from Bas. He's got a nice pair. So normally I would take out the fiat currency and pay Bas and get the alpaca socks. That's not the way it works on the blockchain of the Bitcoin. I use the Bitcoin as an example. The blockchain has many applications, but we'll go into that later, and also Dave will address that. But first, I want to show you how it works on the blockchain. So what we see here is a giant room with all these small houses. They are unbelievable, but you can look right through. So any piggy bank we've got there is visible for everyone. And suppose we have cameras here. Imagine we have cameras here in this room, which record every motion in the room. Every movement is recorded. And also the footage of this camera will be online on the internet forever and unchangeable. You can't change it. So if I step in this room, I won't go in like being Henk. I just go in there and I wear a ski mask and wear sunglasses because I don't want to be recognized. Maybe want to be anonymous. So I go in there, I take out the coins, and I'll pay. I can put it in the public address. I store it in the public address of Bas. This is on the blockchain. This is an intention. I can't do it like this. This is an intention. So I broadcast this intention that I want to pay Bas to the world, to the internet. Let's not make the mistake that I say web. So I broadcast it on the internet. And on the internet, we have all these computers interacting with each other to validate this transaction. This transaction from me to us has a key. I need a key to open it. It's a private key. It has an address, a public key. Everybody could see that there were 3 euros in there. And anyone could see after this transaction is validated that there's 1 euro in there. This intention, we can make a fingerprint of this one. So we won't store all the data that is connected to this transaction. We use a fingerprint. I'll get back to that later. All right? So now the blockchain itself. Has anyone questions on this one? On how a transaction works on the blockchain? No? Clear? All right. We have this. We'll start using a network of interconnected computers. And these are representations of the blockchain. I'll give you one too. Oh, you have a nice one. I use one myself. So when Satoshi Nakamoto first, in 2008, wrote this paper, I'll show it to you. It's 8 pages A4 description of how a peer-to-peer network needs to work to be able to have the trust decentralized. So we don't need a trusted third party to validate a transaction from A to B. And there's a lot of cryptography in there. There's some procedural aspects which he programmed a year later. And there's also, and it's very interesting, gaming theory in here. So actually he makes it a sort of guessing game. So if you guess the right number, then you win a kind of lottery. And the one who wins the lottery, that node, and that's you or me, that node decides on the transactions that are in this lottery. That's difficult, isn't it? I see people rolling their eyes here. But we'll get back to that. How does that work? Let's get back to Satoshi Nakamoto the first time he started the blockchain. That was in 3 January 2009, and he had 2 computers, let's say both of us. So we have these nodes, these are computers, calculating this kind of game. And what he did was he transferred between 2 computers an amount of money, and he validated that transaction. And how do you do that? That's just take the first cup, and you can do that, and put in the hash of the transaction, which I just explained between us and me. So there's a fingerprint of this transaction. It's put in this cup. And then the computer starts calculating a mathematical game. And the mathematical game consists of the wanted result that there's a 0 in front of a hash, a certain hash. And the hash is something like cryptography. And it's called SHA-256. You can forget that later. But it's a way of cryptographically sign any amount of data. Any amount of data gets a fingerprint. So if you just put in 1 0, it will get a fingerprint of 256 bytes. If you put in, let's say, the whole world digitally, it will still present one single string of 256 bytes that represent, fingerprint, this amount of data. And why do we need to know this? Why is it so important that we actually know how transactions are validated on the blockchain? The answer is simple. If we don't get the message of the blockchain, we won't accept the potential of the blockchain as well. We always would think, well, we can do that already. We have computers enough, we have the web, we have the internet. So we have to really dive into this and understand how it works. So we have here what we have here is transactions in this cup, and the calculation that tries to find a number which starts with a 0, a whole string that starts with a 0. And if, for example, I find this number first, we have all the same input. All the transactions are broadcasted around the network, so everybody has the same input. But there's only one node, one computer, or part of computers, that finds the right answer to this question. And I would say, well, I got it. And then you 3 can all validate pretty quickly that I'm really sure about the fact that I have this 0 found. I have the solution, and you can check that. You can validate it right away. And
We all have the same input, right?
exactly.
And the algorithm always produces the same output.
Exactly.
But what's the...
There's
if
one
there's always,
small-
always the same output, then
yeah.
what's the guessing game?
That's a good question, because then you would say everybody produces the same output all the time.
Right.
Right. There's one small difference. We have all the same input, except for It's called the nonce. And it's, no, that's not. It's called the nonce. It's a number. And you add it to the string that we have.
It looks like a random number.
Exactly, it's a random number. And the hashing algorithm works as follows. If you change one single bit, the whole hash will change totally. So it's really a random generator, and it will be a game. It will really be a game.
And the rule is that the output should start with a 0.
Exactly. That's one. The first.
Or there are many rules.
Exactly. I'll show you later how it works.
Okay.
But first we have to do this blockchain thing. I got bingo. So I would say you check this and you agree on the fact that this transaction is in here is valid, and we could turn it on.
Because in the meantime you give me your notes and then I can check it.
Exactly.
Okay.
I gave you the whole
Right.
string of input that you can validate that I produced 0
Right.
in the first one. All right? But that's how it works. Is everybody still with us, or have I lost a few people on the way? You're not sure? No? No? Okay. Tell me.
I'm still thinking.
Where did we lose you?
Going forward, maybe I can.
Okay.
My knowledge.
I have a small film as well, and I will show you how it actually works too. So, this one is done in 10 minutes. And on a blockchain of Bitcoin, we will validate a block in 10 minutes. So every 10 minutes, we will validate a new block. And what do we do in the next 10 minutes? This is our next plastic cup where we collect transactions. So the first thing that goes in there is a fingerprint of this one. Why would we do that? Why would we make a fingerprint of this one with all the transactions in it from the past 10 minutes since the Genesis block of Satoshi? Why would we do that? Fingerprint. Any ideas?
Create the chain.
Sorry?
It creates the chain.
To create a chain, exactly. It creates
You
the
have to
chain.
base upon the previous result.
Exactly. Yes, and we don't need the whole data in there. We just need a fingerprint. Because when we use the fingerprint and we would change a single bit in that fingerprint, the whole outcome of our next validation of the block would be different, wouldn't it? All right. So we collect again all this data and we put next one. Okay, we go now a bit rapid, more faster. Sorry. And we put. See, there's a note not functioning quite well. Yeah. So then we take the next one. All right. Now we see a few notes that don't know what to do. Here's a note he doesn't know. So we have a yellow here. What happened to this one? All right, you got it there. You were in front. You were in front. So what happened here is I tried to cheat. I tried to cheat the blockchain. What I did was I just took another color and put it on the red one. All the others have the red one. And what the blockchain of the Bitcoin says is we accept the longest chain. So the validity of the longest chain is ruled. As long as more than 50% of all the nodes, we have 4 nodes here, but in fact there are 7,000 nodes broadcasting, receiving transactions, sending out messages around the world, 7,000. As long as 51% of all these nodes send the same story about the truth, and the only truth we accept, then all the others will have to accept it. And that's the longest chain. So a cheater like me will be very obvious right away, because all the others will have the red one here. Now we'll put a wrong one over it. So they will discard that, and the longest chain will go on. I'll show you then how it works. I'll have to find it first. There it is. I'll show you how the game works with the cups. If we have a random number here, and we would say this is the fingerprint of the last block we validated, then this generates this number. So this is the next number, but there's no zero in front of this one, so we haven't had any solution yet. But as soon as we start accepting transactions which have a fingerprint of their own, we'll just make a few. These are just a few transactions. Yeah. So you'll see it produces different hashes, right? So if I just change one single bit here, the hash will change totally, and that's the basic of finding the right solution here with a few zeros up front. So in the beginning it was easy. Satoshi Nakamoto only demanded 1 0 in front of this hash about finding the right solution and saying, well, my transactions are the valid ones. By the way, it's also the double spending problem, which I won't go into further detail, but this mechanism solves the double spending problem as well. What we have to do now is the nonce, the only single character or position that changes, we can iterate that one. See, and the hashes change. And we have to go on and on. And that's exactly what all these nodes and these mining parts do. They simply go over all these numbers, trying to find a solution to this mathematical game. And when I get one, you will help me to say a bingo here. I don't know how far I should go with. So now I'm incrementing the nonce all the time. You see what happens. The SHA changes, but unfortunately, yes, bingo. So now I will broadcast bingo to the network, and this is our input. So what all the other nodes are going to do, they're going to validate whether these transactions are valid. So maybe this transaction is invalid. Then they will discard the whole block.
So in other words, as soon as you guess the number, the hash with 0, starting with 0,
Yeah.
you send to all the other nodes your input and the hash you created. So other nodes can take input you sent, recreate the hash, and compare with the one you sent within aside the inputs itself.
Yeah. That creates the chain as well. And how is that done? You can see it happening here. We said 1 0 is enough to solve the game, and that solution is also the hash that goes into the next block. And that's the way we create a chain. If we would want to change a transaction which has been validated an hour ago, that's 6 blocks. Then you have to regenerate and do all the work, do all this work to regenerate blocks this way. You can't change a transaction that's been done 6 blocks away. And all the history is compact or is secured in a single fingerprint.
And something, sorry, may I ask? So in the line that you just inputted, each number before one of those hyphens, or how you call it, streepje, is a transaction. How can you know if an individual transaction is valid or not?
double spending, then I need to explain the double spending problem. Any node can collect transactions, and if somebody who cheats sends, for example, when I would send more euros from this address to several other addresses, that would create more than one transaction. And it's just nodes, they pick randomly transactions from an address, and they will discard as they come in. And they will discard any other new transaction that has the same public key, same address. They will just say, well, I discard it. So if somebody comes up with a transaction and a solution and has the longest chain and has a solution to the mathematical problem, then they will accept that and will discard all their own and will go on. Yeah? Is that more or less?
I hope that I can remember.
Well, you don't have to remember, but as long as you, if you could, it's like learning you how to drive. I could tell you how to drive a car, but I would never know where you end up. We could do some test drives, and that's what we're doing here. So we do a few test drives, and then you get to know the vehicle, and you know the interiors, and then we'll see where you end up with your image. All right, so in fact what we do then is we'll take a small part of this new fingerprint, and then we go again. We receive all these transactions, and we'll end up with the nonce, and we try to find again a zero. How hard is this? For example, this word produces 4 zeros, and there's another one which I forgot, produces 6 zeros. But it's a very hard. You do have to do a lot of work, mathematical solutions, and miners have built enormous amounts of computers, specialized computers, to produce a lot of hashing power. And what is hashing power? Hashing power is not more than what I just showed you, trying to find as quickly as possible a hash that has not 1 zero, our example, but has like 25 or 30 or 40 zeros. That's a really hard problem, and all these nodes have to calculate that, right? Now, this paper has written it all up front, and it says the majority, as long as the majority of the CPU power is controlled by nodes like S4 that are not cooperating to attack the network, will be safe. The other way around, if somebody ever achieves 51% of the power to control the network, we have a problem with Bitcoin. And maybe a few people remember.
How many in China?
Sorry?
How many in China?
There are, well, not enough to cooperate to reach the 51%. But it has occurred that a mining pool has reached more than 50%. They deliberately, voluntarily gave up their power, and well, they regrouped in other groups to not be able to take over or centralize the Bitcoin blockchain. So this is a serious concern. But it's a peer-to-peer network. You don't need any intermediate. It's open, it's transparent. It preserves a history that cannot be cheated or compromised. And all these characteristics, you can't find that in an intermediate-based way of transferring value or storing value. And that's the real promise of the blockchain. Right? Are you still with me? Any questions so far?
What happens if the blockchain is compromised, like you just said? What happens? Is there a fork, or?
Let's say, for example,
what's the impact of a breach?
let's say if China would install an enormous amount of computing power, hashing power, and would January 1st next year say, well, we'll go and say what the real truth is about the transactions in the past. Well, then they'll be laughed at, because there's so many other nodes. They work like meerkats. They're standing, and everybody's on the lookout. And if something ridiculous happens, like China producing like ridiculous amounts of changes on past transactions, everybody will be warned and will duck under. So I don't think there's a real problem.
So you actually, the intent to change the past.
It's all open and transparent.
So if you were to attack the blockchain, the intent of the attack would be to change the past.
Exactly. Yeah.
Okay.
Yeah. Because otherwise, so all these blockchains, we have this, what we described here is proof of work. You have to do a lot of work to find a solution, and being able to say, well, these are the real transactions.
Right.
We validated transactions.
Right. Okay. Okay.
Yeah, you're fine. Right. So there's also proof of stake. It's something else. It's another way of gaining consensus without the need of a trusted third party. And I think David will go into that.
Oh, they mentioned something about proof of work versus proof of stake.
There's another question here.
If the Bitcoin community decides to make some changes in algorithm, how are we going to broadcast it through the whole nodes?
I haven't got that. I'm pretty deaf, so.
If the Bitcoin community wanted to make a permanent change in the Bitcoin algorithm, how would that be broadcast to the nodes?
Okay, that's a good question. Well, there has to be consensus on that too, so they will vote on that. And
Technically, I mean the technical procedure. So every node should update their software or how
yeah,
it works.
that's true. And you have two types of that. You have a hard fork or a soft fork. A soft fork is an improvement or a change which is built on top of the current algorithms and procedures, let's say more or less. And a hard fork is that you're going to change the way it works at the moment. And you have to have more than 50% of the nodes, or even more. I don't know.
I think theoretically,
At least the majority.
in Bitcoin, you need to have 51%, and then you can impose a hard fork. I think the best way of looking at a hard fork versus a soft fork is that a hard fork you will end up with two Bitcoin chains which are mutually incompatible. A soft fork maintains compatibility between the new versions and the old versions. So you may have one version that can be pink and one version that can be purple, but they can operate perfectly well together. Whereas with a hard fork, that compatibility is gone. Pink goes this way, purple goes that way, and they won't come back together again unless somebody takes some drastic action.
It's nearly impossible for the Bitcoin blockchain to hard fork, because the fact that there's so much at stake, the Bitcoin is worth a lot at the moment. If you just fork, it would be disastrous. There has to be some sense of majority that wants to go this way, and especially unanimous. That's the right word. You have to be unanimous to keep the value, and that's one of the biggest dangers to Bitcoin is that they can't change. And that's also the answer for block size. There's much debate, but you need a hard fork for this one. I don't know. Pose this question about block size here. But this is a hard fork.
It's impossible to update all nodes simultaneously because there are so many nodes, and sometimes some nodes will work with the old algorithm and some other nodes will work with the new algorithm. And how the network can handle this situation of where two forks work simultaneously.
The honest answer is I don't know. They certainly do not. I don't know how to manage that change. And what I do know is that this represents, it's blockchain.info, it represents the numbers, the transactions. It's a live feed of 7 seconds per, 7 transactions per second. And this is, simply compare this to a bank. You can't see this at a bank. The bank won't show you how it does its transactions. If you click on a single transaction, you will see the incoming and outgoing address of the Bitcoin, and you can see the amount of Bitcoins that's on the address before and after the transfer. So this kind of openness and transparency is very new.
It's just like 5 transactions per second. Is the whole transactions percentage here or not?
Sorry?
It's like about 5 transactions per second.
Yeah,
Is it the whole transaction in the world of real time?
yeah, but you know, they can't keep up with the real speed. I think they leave a few
It's
out.
more, so
Yeah,
that's-
I think it's more.
It's a lot more actually.
Yeah.
If you look at it is interesting to speak about the block size discussion in this. If you look there, you see the size of a block. The top line, you see 999 at the right. That means that the block is full. 4 blocks in the last month have already been completely full. So the network is at capacity at the moment. This is a big problem for Bitcoin at the moment.
But
That is where the block size debate comes in.
Exactly.
There's a simple solution. If you increase the size of each block, currently each Bitcoin block is 1 megabyte.
1 gigabyte.
Yeah. And there are several competing solutions to move it either to 2 megabytes or to 8 megabytes. Keeping the same 10 minutes in between each blocks means they can stuff more transactions into either 2 megabytes or 8 megabytes, and so give what appears to be faster transaction speeds, or at least better transaction volume. But this is a very, very big discussion.
if you compare this to Visa card and MasterCard, they will do 2,000 transactions a second on a New Year's Eve. No, on Christmas Eve. So that's a totally different ballgame there. And we don't need to compare because a blockchain delivers freedom in return for less efficiency. So the fact that all these nodes have to count, produce a lot of, or use a lot of energy, and being very ineffective. Let's say, if we would see all those nodes in 3 years, they would consume the same amount of energy that the whole of Ireland would do. So it's a lot of energy wasted because only one node can win, but they all have to do the same work to being able to validate the transactions. So it's an enormous waste of energy and very bad for the planet. You know, Satoshi wasn't perfect. He just had a very good invention with the blockchain under the hood.
Will it increasing the block size affect the transaction speed? Or increasing the block size that's lower the transaction processing speed because now it's like 7 seconds per second. So increasing the block size would that affect?
That would, in theory, multiplied by a factor of 8, providing nothing else changed. But then when you factor in the overhead processing and the amount of communication that has to be done to get that 8-fold increase, you're almost certainly not going to see an 8-fold increase. You may see a 4-fold increase. Either way, simply increasing the block size is not really a solution because at a certain moment, the amount of data that every Bitcoin node has to store is going to become unhandleable in some way. And this is the reason that Bitcoin is probably not going to be able, or one of the reasons why Bitcoin probably won't be able to scale to become an actual global currency. Right now, it is literally sort of bouncing off its limits at 7 transactions per second. They could fix that to 14, or maybe up to 40-something transactions per second, but it's still never going to approach the level of transactions that something like Visa or a truly centralized system can handle. So there are ways of crashing this problem, and this is the quest for scalability. There will eventually be a cryptocurrency that can, in some way, handle the global level of transactions. But so far, that's something that hasn't actually been figured out yet. Though NXT is making a couple of steps in that direction.
There's somebody who wants to enter. Join in. So what happens now to all the intermediates? We can use the blockchain not only for cryptocurrency, but also for contracts, for assets. There's a lot of new applications. There's a potential promise of the blockchain. And if you would, I want to give you a feel of how that is, how the reception is in the current power blocks like banks, insurance companies, and so on. Suppose we have, is there any Peter in this room? No Peter, so you're Peter? All right. So we can say, we can name our banker Peter. And Peter has done a great job. Last 30 years, he's been working hard to make transactions from A to B, and the world is internationalized, it's digitalized as well. So he has these many attacks from the internet trying to rob people of their money and rob the bank of its money. So it's a very hard work he has now. And it's more or less like Peter is sitting on a bicycle with square wheels, you know. It goes like that. So that's very hard to move forward. And then in the end he sees like whoosh. Satoshi on his bicycle. He's got round wheels. They're made of wood. They're a bit noisy. And they might break or not. And what does Peter do? Tell me, what does Peter do? He's sitting on his bicycle, square wheels, laboring hard all day, trying to make these transactions work between people around the world. What does Peter do when he sees Satoshi on his bicycle?
He's too busy to change.
Sorry?
He's too busy to change.
He's too busy to change. Right? It's inevitable. On the back of the bicycle says, buy Bitcoin. You know? You can see that. So what does Peter do?
Tries to look in.
Sorry?
Tries to look in.
He has to
ride along with Satoshi.
Okay, he could do that. I don't think that's the first thing.
Steals his wheels.
He steals his wheels. Yeah, that's exactly what they're trying to do at the moment. I would say,
Curses.
sorry?
He curses very
Yeah,
hard.
Exactly. Firstly, he will be surprised. Then they will be angry. And what they try to do is they take out the guns and shoot him off his bike. That's what they tried. But they didn't succeed. And then the next step is that they try to buy themselves in. That's what Ross said. And then afterwards they have to blend in. They have to adapt to these public blockchains like Bitcoin. Because there's also what Dave said, there's also a situation that they can capture or, let's say, take the technology as a hostage and build their own private blockchains. So private blockchains are totally, well, not totally different, but they're quite different than public blockchains. Private blockchains are still controlled by centralized parties, like banks, insurance companies. But you'll hear a lot in the near future in the news about banks and insurance companies having their own blockchain and perfectly adapting to the blockchain like they invented the blockchains themselves. You will hear that. And what I hope is that you will be able to evaluate this kind of news and know what is rubbish and what is true. You have to make the distinction yourself, because there will be a lot of media or news in the media that's not really about public blockchains, but about, instead of that, about private blockchains, right?
What are the benefits of using blockchains if it is private? If we still have parts that control it, what is the sense of using blockchain then?
The sense of there are quite a few efficiency advantages for using a blockchain, because many intermediates have built for centuries procedures and tools to do things the old-fashioned way. And then comes an accidental invention like the blockchain really is, and does things without the need of any intermediate, much more efficient. So that's a reason why you could easily take this technology and improve the business you've done before. But it's rather boring. If you compare that to the public innovation, it's the private innovation is rather boring game.
Do you think that they can't coexist?
Sorry?
Don't you think that they can coexist? Private blockchains and
I think so, yeah. The question was, can they coexist, the private and the public blockchains? I think so, yeah. And there will be hybrid forms as well.
Why is it
Why
boring?
Sorry?
Why would miners be interested in
Miners.
permission blockchains? Because they can't sell their coins.
Exactly.
to anyone.
That's a good
If there's a
question.
list of coins, you want coins,
Yeah.
money typically that is accepted everywhere, not on a permission
Yeah.
system.
So if you go to the heart of a blockchain, it's a network of trust, and you need some kind of proof of work, or proof of stake, to validate transaction in that. And if you pay miners either to validate the transactions or either simply because they won the game, which we talked about that before you came in, then it's makes no sense for them to calculate on transactions in a private blockchain. So they will use, for example, other proofing mechanism, other consensus mechanism that might work for them. But the main difference is that a private blockchain still is
When you're
centralized.
talking about a blockchain, what kind of consensus system are you?
Sorry?
What kind of consensus system do you have in mind?
There's quite a few consensus mechanisms available, but the main
Can you
two
give some
are
examples?
proof of work or proof of stake. And we just I won't go into detail of that because we've had it before. We
Yeah,
explained our proof of work. Yeah. So there's quite a few. But
Yeah, so if you're a miner,
yeah.
you're going to mine on a private blockchain, receiving tokens from a private system,
Mhm.
which have high value because of anonymity, for example. But you can only sell them within this
Exactly.
permission
Yeah.
system.
Yeah. I wouldn't go there.
That's
I wouldn't go there.
wrong, right?
Exactly. Yeah. It makes no sense.
So, private blockchains.
They're a totally different ballgame. I think we agree on that. That it's a
But
totally
why is it
different-
boring? Because I suppose you're ING and you have worldwide branches, you have 2,000 branches worldwide, and each branch you give a node. Then you can have your entire own transaction
But
mechanism
it's
internally
still-
within the company.
Why is it boring? That's a matter of taste.
Okay.
I find it boring because the real innovation comes from the blockchain technology that's publicly exposed,
Sure.
and that's where the real.
But it can have a valid function.
Of course, but
for
it's still
companies.
centralized. I
Right.
mean, if we are discussing the freedom in return for less efficiency, which a blockchain obviously is, then you don't need a private blockchain to do that work, because a private blockchain is still centralized, it's still under the command of the ING.
Right.
So,
Yeah, that makes sense.
okay. I'm going to wrap this up. We'll see this guy on the square wheels, and what is the blockchain promise? Doing business directly. The rules of engagement are preset. Well, you can read it yourself. This is a very important one. We won't have any more Watergates. We won't have any more paintings being forged. We won't have any diamonds anymore that are falsities, glass. Because of the simple fact that we put signature, fingerprint of this diamond on the blockchain.
This is actually already being done, by the way.
Yeah.
There is a large diamond consortium that is already putting all their specific diamonds on the blockchain, completely verified. It's awesome.
This is how you're going to see blockchain actually in your life, in working. We've talked a lot about Bitcoin. That's only number one. It's only the first line. Colored coins is an example of charity. Hello. So I could give an example of colored coins here. This, for example, if you give now your money to UNICEF, You have to have trust in the fact that they will use it rightly, they will use it now, and they will use it to fund the right people that you intended to reach, and you hope that they will send 100% of this money to them. Now, how applicable is that? I don't think so. Most of the money given to charities stands there for years, and 96% will be consumed by the charity organizations themselves. How can we change this field? Well, simply say to any creator of a blockchain, could you make a smart contract between any benevolent person in the world and any kid that has no money at all for education and for healthcare, and they have to live in Africa? When somebody makes a blockchain like that and a smart contract on that, you could send colored coins to these kids, and you would say, well, if you use my money for healthcare, for education, be my guest. But if you want to use it to go and buy ice creams, it won't work. And in the end, if you don't use it at all, I will get my money back. This is no futurology. This is factual application of possibilities of blockchains. This is how it can be done and will be done in the near future. And that will result in the fact that you can give 100% of value directly, open and transparent to any kid in the world. And I think that's a really motivation for me to be in this line of work, to get that done. These are a few roles we might have discussed before. We've seen exchange. We didn't talk about wallets, but they are there. Be careful with them. You have merchants and users, the nodes we've discussed. One word to remember is atomic. I got that from a book, which I also can recommend. It's this one. Bugaya. It's called the business blockchain, but it's really a very extensive discussion about blockchain. And I got this from him. And what is the blockchain? What does it offer? Well, these things: asset, trust, ownership, identities, and contracts. Any questions? I think you have a few questions because you gave the feedback.
I'll come to that later. Thanks.
Any other questions?
What about contracts? What does it mean when people get it? What do you mean for contracts? It's a relationship within two entities, and how it's done by doing simple transaction, or something which is more modular somehow?
Well, in fact, if you look at the Bitcoin blockchain, there's some sort of contract in there, isn't it? As soon as you broadcast your transaction to the network, your money is gone. That's for sure. All right? So that's a very, very thin definition of a contract. Your money is gone forever. You're sure of that. So if you would make a few more, let's say, modern contracts, smart contracts, you could say, like we said before, you can use this money unless you are a certified partner, for example. Or we send this money, but we multi-sign this money. So you and I both have to sign before Bas gets the money. It's still very thin definitions of contracts, all right? But you have very, what would you say, elaborate, extensive.
You can make quite, well, in theory, because most smart contract systems haven't actually got a smart contract phase, they're still a dumb contract. Ethereum's really the leading example of a platform that will support smart contracts. But the idea is basically to be able to create a rules structure that can then automatically handle all of the various transactions for you. So for example, if I was working as a coder, I could have the system set up that I get paid when I actually deliver code and submit it to the project. And that could also be automated. The project itself could monitor my performance, see that I've delivered the correct code, run the Q&A on the code, or run QA quality assurance on the code, and think, yeah, Dave, he deserves to get paid. So then that contract will then release funds to me and to my account. After that, I could, for example, have smart contracts set up on my own personal cryptocurrency accounts that will automatically take my irregular income from coding, split it down into a nice sensible monthly sort of breakdown, for example, into 12 sections, and then actually use that every month to pay off my rental mortgage. Basically, any sort of legal construction or financial handling construction that you can think of can and will eventually be encoded in the blockchain, so that you then no longer have to worry about actually micromanaging your own finances. You set it up once and it will run for the rest of your lifetime. And you won't have to worry about actually security and checks on how your finances are working. The Bitcoin blockchain contains all of that. It takes the necessity to trust a third party or to validate transactions away, providing the blockchain is working correctly. You know with 100% certainty that everything in that is running the way you want it to. So that's pretty much what smart contracts are going to be. At the moment, we're at the level of double contracts, which is money comes in, money gets split up, passed over to two parties, or money comes in, 5 parties vote on where the money goes, the majority decision, money is transferred. But in 5 to 10 years, you're going to see much more elaborate smart contract structures.
We'll have pension contracts, which are rules of engagement preset, which can't be changed by any of the parties. And what we see now with pensions is that the trusted intermediate central power party says, I can't pay you the pension, you have to pay more rent, etc., etc. I see laughing faces at the moment. So that game will change a lot in the coming 5 or 10 years. I hope you guys have grasped the idea of how blockchain works in detail, and I hope you continue to recognize all the innovations in this line of work in the coming years. Thank you for listening.